sure you draw them, and for the most part, they look good. But I mean, we don't have to like, go 1, 2, 3, 4. I mean, in this case, we're just looking for the general shape. And make sure you the mistakes I'm seeing is you're going in order of what you see up here, but not in order of the zeros. So that is 4, which is over here. This is -3, and this is 1. So every now and then I'm seeing, all right, this is a bounce. So you're making the first one bounce because it comes in that order. Make sure that it bounces at the 1. Okay, don't just go from left to right and go, whatever, bounce, bend, straight through. So here, so the x plus 3 goes straight through. It's 2, 3, 4th degree. And now it won't bounce until it gets up to the 1, and then it goes through. Okay, so make sure it's clear, the shape. Okay, the shape is clear. So 68, those both bounce, and everything looked pretty good on those. But for the last one here, all right, that hits at 1. I'm going to spread that out a little bit. It hits at 3, and it hits at -2 for them. But you got to watch it. -2, that's where you have the what? You have the bend, and when you're drawing it, make sure you kind of come down, and what do we got there? 6 degree. Kind of go to the left, and then as you get to it, kind of bend through, and then what's happening at the 1? Bounce, and then it goes straight through. Exactly what lanes look like. Okay? So make sure you have those clear, clearly marked. All right, we're going to do a couple other things. Go from that same thing. Open up your books, get your books out, and then you can either do it on here or start a separate. We're going to do some more of the problems out back. There's a couple like special cases that I need you to see. So what page was that?
327.
All right, 347. Well, don't start anything yet, even though it's do not. Just wait a second. So yeah, flip it over. Actually, be on 348. Oh, it's 348. All right, let's actually start at 71. Go to 71, write that problem down. Let's take a look at what that graph's going to look like. All right, now for 71, we haven't come across this yet. How is this slightly different? You got your negative x squared, you got x squared minus 1, and you got x plus 1. What do we got to do with that x squared minus 1? Okay, or is that going to give us any roots? What's happening there? Ryan?
Is it a difference of squares?
It is a difference of squares. It can be factored. Okay, so looking at that, you got to be careful. You can't just say 1 is a root there, or -1, or that. Yeah. All right, thank you. That's for you. So factor that. So f of x equals negative x squared. Well, x squared minus 1 is x minus 1 times x plus 1. And then you also have an x plus 1. Okay? Now, what we can treat that as is negative x squared, x minus 1, but we have, how many x plus 1s do we have? 2 of them. So that's going to give you a multiplicity of 2, or you can write it as x plus 1 squared. Usually you've been given everything, but now you can, you have to create that x plus 1 squared. All right, you have your roots at 1, 0, and negative 1. I do not want to see them jammed together like right here. Spread them out. So I'm going to go 1, 2, 3, 4. I'm going to make my negative 1 way over here. Okay? Your graph needs to be clear what is happening. I'm going to make my 1 way over there. So I got x equals 0, multiplicity of 2. I got x equals 1, multiplicity of, what is that, 1? And then I got negative 1, which is a multiplicity of 2. So I got 2 bounces, 1 straight through, and then what is my overall degree? Well, overall degree is 5, and then what's my end behavior? Okay, end behavior. Is it going to be a negative leading term or a positive leading term? Negative because of that x squared. So end behavior has to go from high to low. And so it has to hit at negative 1. Now make sure you identify, just don't go in order. Negative 1 has a multiplicity of 2. So it bounces. 0 has a multiplicity of 2. So it bounces at 0. And what happens at 1? Goes straight through. Goes straight through. All right. Graph on your calculator. And we're going to make it look, you are going to make it look just like that. Now you can graph the original, it doesn't matter, or you can graph the final factored version. So negative x squared. And I'm going to go back to the original one, x squared minus 1 times x plus 1. All right. Okay. All right, so the way mine looks, can you tell what's going on? Absolutely not. Okay, because it's too congested there. So you need to learn how to do this. How do you change your window so that you can at least see the shape? What's it going to look like? So you can at least see the shape for that. Well, do I need to go all the way on the x direction from negative 10 to 10? No, I don't, because it's really just concerned around negative 1 and 1. So I'm going to change mine to negative 3 to 3. Now I want you to think how you're going to change your y window. So go ahead and you mess around, see if you can get it to where you can see what is going on. I know you got a watch right here. Can't make it like I can. It's got to come and like bend back. Okay, so that's what it's saying. All right, what do you got for your window? Aaron Hess, what do you got for your y window?
For y, I have y min is negative 1/2.
Negative 1/2.
And for y max, I have 1/2.
And you got 0.5. And I'm going to go every 0.25. Okay, does it now look like what we talked about? Okay, so we had to go in pretty far, okay, for that, but at least you can see the general shape. The general shape matches what we said it should look like. It should have a bounce at -1. It should have a bounce at 0, and it should go straight through +1. So you need to be able to manipulate your window so that it matches what you say it should look like. So if you're at the normal graph, you can't tell me that that is the same as that. So you might have to be able to manipulate that a little bit, okay? All right, so that was what, 71? All right, 72, go ahead and do that one. What do you think we need to do with the x² - 4? Okay, so think about you're gonna do that and just sketch it. You can draw it, do it on your calculator if you want, not necessary though. All right, so you got here x² - 4. So make sure that is x - 2 times x + 2 times x + 2. And so now you get x + 2 quantity squared, okay, for our function. So f of x equals. So we got a root at 0. All right, I just got 2 and -2, so I'm going to spread those out. So 1, 2, 3. And actually, I don't really care a whole lot if you just go, slap a -2 down and slap a 2 down, make sure they're far enough apart so that you can draw it accurately, don't jam them together. But this is a 5th degree positive, so the end behavior needs to look like this. And then at -2, okay, make sure that it bounces because that is the one that has a multiplicity of 2. At 0, it bounces, and then at 2, it goes straight through. So it should look something like this: bounce, bounce, and right through. Make sure that this is a clear hill. One thing you don't do that it's easy to do here is don't do this like that. Just make sure that straight up. Make sure there's a clear rounded off once. That's why you got to spread it out. All right, so that was 72. All right, now let's take a look at 73. Let's take a look at 73. All right, I want you to put down whatever you think it looks like, and then graph it on your calculator. And if you just can't figure out what it looks like, go ahead and graph it on your calculator and see what's on there makes sense after you've after you look at it. All right, if you graph it, this is what it looks like. What happens at 0? There's a what? Bounce. At 2, it goes straight through. Now, the question is, what's going on with that x squared plus 1? Okay, where is it showing up at? Or where is it not showing up at? Okay, does that factor? Okay, it is not a difference of squares. X squared minus 1 factors into x minus 1, x plus 1. All right, now you've always been taught, once you get it in factored form, we say you set it equal to 0, and this is how we get our answers. X equals 0, x minus 2 equals 0, which is x equals 2, so those are our roots, right? Well, what happens when I set this to 0? X squared plus 1 equals 0. That gives me x squared equals negative 1. What do? X squared equals negative 1. Take the square root. What's the square root of negative 1? I. And I is what type of number? It is an imaginary number. This is the real number system. I is not on here. So you can't plot it on here. So it does not show up as a 0. Okay, it does not show up. So it's still 5th degree. It's got to follow your 5th degree rules. It has a positive leading coefficient, so it starts down and ends up. But this will not contribute any zeros. Okay, only real number zeros will show up. Okay, imaginary zeros do not. So it just bounces and goes straight through. All right, 74 is going to be similar. Okay, just look at this one. What about x squared plus 9? Will that give me any real zeros? No, so that will not show up on the graph. This will give me a 0 at x equals 0, and this will give me 1 at 2, but a multiplicity what? 2. So now it hits at 0 and 2. What degree is the function overall? It's still what? 5th degree, positive leading coefficient, but at 0 it has to go through, and at 2 it has to bounce for that one. So we haven't come across that yet. So the kind of the cases here is if you get a imaginary root, it will not show up, but you also have to double check to see if something factors again, and that will add a root for that. All right, take a look at 85. Take a look at 85 down that next page. Read through it. Part A says find the volume as a function. So you want to create an equation to find the volume. All right, see what you come. I'm going to give you a little bit of time here. Hey, once you get the function, don't multiply it out. Just kind of wait. No, I wouldn't multiply it out. So see what you have written down.
What sheet can you get the volume on? Just these boxes? Or it's like everything?
That's not a problem.
Oh.
Just fold it up. Oh, everybody knows it's what, length times width. But,
Yeah.
give you an idea. Look at that.
Wow.
You're close. All right, let's make sure you understand what's going on. So here's this little piece of paper. I cut out 4 corners, right? So you fold them up. And then what do we create? You create an open top box, right? So we're going to do volume. Volume is, generally the volume is length times width times what? Height. Length times width times height. So volume. But this value here is changing, right? It's not the same. Okay, so you just can't say, oh, it's 1 inch or it's a half an inch or whatever. It's changing. So we label it X. We label it X. So that is going to be the same amount at each corner that we cut out. Let me talk about the height first. What's the height of the box? If that corner is X and we fold everything up, what will be the height?
X.
The height is X. So let H, our height, is going to be whatever that distance is. All right, what is the length? Well, the typical length is 15, right? Typical length is 15. What's going to be the length of the folded up?
15 minus 2x.
15 minus 2x, because you're taking out this x here, you're taking out this x here, and so the length will only be from here to here. So it's 15 minus 2x. Well, the width is 8. But we are cutting out an x here and an x here. So when we're done, it's going to be from here to here. And what's it going to be, Cooper?
8 minus 2x?
8 minus 2x. So what does my formula look like for volume? What does my formula look like for volume? Length times width times height. So what's my length? 15 minus 2x. What is my width? 8 minus 2x. And what's my height? Don't multiply it all together. Leave it. Leave it. All right, so that's part A. What's part B ask you to do? All right, we got to sketch it. Can't use your calculator yet. We got to sketch that graph. All right, now I want to ask you one thing here. Common sense here. Look at this problem. What is the biggest amount X can be? What is the biggest corner I can cut out? All right, think about that. And with what you're given. All right. Biggest corner I can cut out. Cole Rhodes.
No idea.
All right, let me ask you something. Could I make this 5 inches? Could I cut out an X value of 5 inches?
No.
Why not?
Because if you do 15 minus 2x, that works and you still have 5. But if you do 8 minus 2x, then you end up with -2, which you can't have.
Right, this is 8 inches wide, right? So I can't cut out 5 inches from that side and 5 inches from that side. What is the most I could cut out from that side? Theoretically. 4, right? Probably be a little bit less than 4, but you can't go over 4, right? Because you can't take more than 4 from both sides. All right, so that's going to come into play. All right, what's this graph going to look like? All right, take a second, see if you can figure it out. Don't touch your calculator. You got enough information to know what it looks like. You have enough information to know what it looks like. And it's just like the shape of it. The zeros, what do we need to know? We need to know the zeros, and we need to know the end behavior. All right, couple key things here. What degree is it, first of all? Okay, what degree is it? Okay, Tyler.
3.
It's 3rd degree. What is our leading term, or how do I find our leading term? Adam Lippy, what is our leading term, or how do I find it?
Sect 15 minus 2x equals 0.
No. My leading term, that's the zeros.
Okay, x.
So we said it's 3rd degree, so like is the first term like x to the 3rd? Is it 2x to the 3rd?
4x to the 3rd.
Okay, you take everything with an x. Okay, now this is a little bit different order than we're used to, right? We're used to everything x minus 2 or x plus 2. So here you just take -2x, so for my leading term, it's going to be -2x times -2x times x, which is going to be 4x to the 3rd. So it's the 3rd power. It has a positive leading coefficient, so the end behavior goes from low to high, right? Now we need the zeros. Now, Adam, how do I find the zeros?
Set 15 minus 2x equals 0.
15 minus 2x equals to 0.
And 8 minus 2x equals to 0.
8 minus 2x equals to 0, and x equals 0. Well, that one's easy. Solve this. Basically, you add 2x. X equals 7.5. 7.5. Add 2x. 8 equals 2x. X equals 4. All right, so I got everything I need. I got my end behavior, I got the degree, and I got my zeros. Can there be any more zeros? No. 7.5, 4, and 0. So I want to graph this. Sketch a graph. So it hits at 0, it hits at 4, and it hits at 7.5. And you don't, for something like that, you don't need to like mark every scale, every one. Just 4 and 7.5. But make sure it's clear how your graph will look. Everything's multiplicity of 1. We said it starts at -infinity and ends at positive infinity. So it goes through here. Okay, that's just the general shape, so that's part B. That is your answer to part B. All right, for this problem, for the volume, what is the only part of that graph we really care about? Okay, Ryan?
Like the bump on top of the x-axis.
Okay, from 0 to 4, because didn't we say what was the maximum little piece we could cut out? 4. I can't cut out 5 because then it gives me a negative volume. Now, this is not a parabola, and that is not a vertex. That is a relative max. Got it? That is a relative max. Really, all that other stuff doesn't mean anything because I can't cut out a piece that is over 7.5. I can't even cut out a piece over 4. All right, now, what does 86 ask you? It says in exercise 85, use a graphing calculator to estimate the largest possible volume of the box, and I want the dimensions of the box. Use your calculator now. I want the dimensions and the largest volume. See what you come up with. So yes, you're allowed to graph it now. And write them down on your paper. The largest volume and the dimensions that will give you those. If you get them. If you're not quite sure, we'll get them. He's smarter than Zoom. What's the what did you do?
I had Zoom fit.
Oh.
I didn't get Zoom.
All right. So look at your table. Look at your table. Okay. Now we're really concerned from 0 to 4, right?
Mm-hmm.
Make sure your Y max is above anything from 0 to 4. Okay, so change that. Well, let's see. Okay, so if I go to my table, I'm really concerned with 0 to 4. And I don't care about those mixes. I just gotta make sure that I go. I don't know if I changed that. If you did, so right there.
I said I don't know how to change all that.
So look between 0 and 4, look at the highest point. Okay? And so you want to be above that with your Y max. The largest point from 0 to 4, which would be 8. You want to be above that. So you go to your window and you make your Y max at least bigger than that. So you can see it. Because that is your scale. So that's what's showing up on your screen. So this is a 10. So that you can figure out what point it is. So you're trying to find the highest points in between 0 and 4. Because that's the answer to the question. That's the volume. Because all the y values are your volumes.
Okay.
So if I do this, I can make it bigger than that. That right there is the highest point. That's what we want to find. So this is going to be your volumes. All right, I'm going to go through it up here. All right, what are the dimensions? Nathan Moore, you got the dimensions?
Nope.
What? You got the max volume?
I think 90.74.
90.74 is your max volume, okay? Why don't you have the dimensions?
Just didn't know what to do.
Okay, I like a little honesty. What x value gives you that?
Like 1.6 repeatings.
Okay, what's 0.6 repeating? I know this is,
1 2/3.
yes, 1 2/3, right? So x is 1 2/3. Well, what does x represent? That represents the amount we cut off of each corner, right? So what's the height of the box? 1 2/3, right? Well, how do I find the length? The length is 15 minus 2x, right? And then the width is 8 minus 2x. So you take 1 2/3, which is 5/3, right? You know, for that one. And we could figure this out. So it's 15 minus 2 times 5, 10/3. And this is 8 minus 10/3. And then what's 15 minus 10/3? That's 45. 35 over 3. What is that? 35. Is that 8 2/3? No. 11 2/3. So it's 11 2/3 by, all right, what's 8 minus 10/3? That's 14 over 3. 4 2/3? 4 2/3. And what is our height? 1 2/3. All right, now, I hate to tell you this, but like once you start doing some real problems out in the real world and do this, like not all answers are like 2 and 4 and 6. Like sometimes you get decimals and fractions. So y equals, what did we have here? We had 15 minus 2x times 8 minus 2x. Oh, what I hit wrong there. I'm just clearing the whole thing. 15 minus 2x. Okay, got it. And 8 minus 2x. Maybe. And then x. Crap. All right, so you look at that, you're like, hey, you can't really tell what's going on. Now this one, I don't need to probably get the whole shape in there because really, what are we only concerned about between 0 and what? 0 and 4. And what does the y value give me for this? So if I look at my table, when I plug in x is 1, that's the amount I cut off. That gives me a volume of 78. The y value is your volume. We want to maximize it, right? So there's a maximum, a relative max in between 0 and 4. So if I look at that table, I got to get at least higher than what I see on the table so that I can see the graph. Well, what's the highest point on the table? It's 88. I need to be higher than that. And so I go to y max and I go to 100. Now for this one, not really necessary because I don't really care what's underneath there, but I'm going to make it negative 100 just to even it out. If you did that, fine, but it's not necessary. So you can see the whole shape, but we only need this point right here, don't we? So second, calculate maximum, okay? And then it'll say left bound, and it'll say right bound. And then I want to guess. And so 1.6 repeating, 1.67, which is 1 2/3. And then you're right, 90.74. So that's something you're not going to guess. That you're not going to guess that value. Okay, so you got to be able to use your calculator, okay, to come up with that. Anything to the right of 4, any of that, we don't care about because it's not relevant to the problem. Maximum we can cut out is 4. All right, so definitely wanted to go through those things here. All right, here's what I need you to work on. On those two sets at the end, they're more like yes or no questions. You should be able to rationalize why. I'm not gonna be big on like explanations right now. So you should be able to kind of figure out why, but it's kind of hard to write it down. We'll talk about that a little bit tomorrow. We will quiz on Monday. We gotta do 3 tomorrow, and then we'll review a little bit Friday, and then quiz on Monday. And that'll be the last summit of the 9 weeks, so it'll play a huge role. Ooh.
That's really helpful. Yeah. That's